So welcome into the second session of tidal energy. In the first session, what we talked about is about how the actual tides are generated into the seabeds, and particularly if you can revise the things that was covered in the first session, it was there are 4 tides per day. It is also called as diurnal tide, that is daily tide. If we can talk about the main time frame, the period of these tides, particularly diurnal tide, there will be 2 high tides and 2 low tides. Combining the same, the day could approximately 24 hours 50 minutes, or it could be specifically 24 hours 48 minutes. In case of semi-diurnal, we are going to divide it by 2. It means that we have 12.25 minutes for high tide and 12 hour 25 minutes for the low tide. So approximately, if we can consider one high or a low tide, it could be 6 hours and 12 minutes approx. There is also a monthly tidal variation due to effect of gravitational pull, particularly of the moon, and we have also checked once about how we can emptying the basin and how we are going to filling back the basin levels in particular way. So this is how the tidal turbines are incorporated in the seabed. The two-way fins, it might be our main discussion. This is the two-way bulk turbine. So during high tide and during low tide, there could be a slanting tip and edges of the blade, and it will rotate in such a way that in both the cases during high tide and low tide the power will produce. So this is what the basic idea of the same. If we can talk about the one little video about the tidal barrages, we are having a dam kind of structure and we are going to incorporate the TG set, that is turbine generator set over here. Slow tide, high tide and low tide again. So if we can talk about over here, it's a dam, over here there is a basin. So during high tide, the dam is going to be filled or basin is going to be filled, and during low tide, forcefully the dam is going to be empty due to natural gravitational pull of the moon on the earth. So this is what the basic concept about the same. Now if we can talk about the high tide and low tide concept, we are having the gate known as the sluice gate over here. If we can talk about the sluice gate, at that time we are having this sluice gate open and close depending upon the area of the basin, and according to that the dam height will be selected. Usually we are considering high head of the water, that is the general concept of thermal power plant. So the thing is that you are going to enclose some area for the construction of the dam, and turbine generator set should be installed over here. So during high tide the water comes in, and now in particular case one turbine that you are not allowing the water to go through the turbine, so you have to do essentially some gates over here and allow the water to go in or out without through this gate and the turbine. So during the period you will generate the energy, the sea level, and this is called the particular basin. Now if you are considering the various cycles, how we can approach this cycle of the sea and cycle of the water that is to be filled in the basin, it must be superimposed. So if you can consider this during high tide, the basin has to fill. During low tide, forcefully turbine generator set has to operate and the basin will empty. At that time the gate or sluice gate is closed. This is the one way of the power generation. We can think, as we have seen in the earlier in this session of the video, we can have the bidirectional way of the turbine. So during filling of the basin and during emptying of the basin, this turbine generator set will operate and you will get handsome amount of electrical output in both the cases. So this is what the stuff of the single basin tidal scheme. This is the top view. We are having open water, or you can say a seabed, where the sea water is available in plenty of the amount. We are having the enclosed basin. We are having a gate. We are having a barrage, or we can call it as a dam. And we are having the bulk turbines, gated turbines, bulk turbines are available in the platform, or you can say a bridge. In between the bridge and ground there might be a DG set that is installed. So during high tide the basin will fill, and during low tide the gates are closed, and this water is forcefully passing due to the natural gravitational pull of the moon from basin to the open water, that is sea. Now this is what the case as a concept of the single basin tidal scheme. Now if we can generate the power for one way, how we can develop this water level? So in the case of remaining output, that is depending upon the power output, is depending upon at what point we are getting the high head, because to generate the electrical energy in ultimate case we are having the head difference over here that is to be incorporated. So at the time when head is small, at this time the head might be large, or at any time that could be a high head or low head. So the thing is that the power output is depending upon the head difference. Now here we are talking about the one-way turbine. So you have to sluice gate to be open, the basin water level will closely follow the sea water level. So this is the sea water level. So during high tide the basin water level will be closely follow to the sea water level once it reach at its crest point, or it is intersecting with the water level of the sea. At that time the gate will close. As the gate will close, there is a concept of the variable head. Now in this variable head, the potential difference has to be maintained between sea. This is the characteristic, obviously, as it is single basin of the basin, so it gets the power output in this time. Now if we can talk about the high tide and low tide, this single cycle of the tide is what we call as a time span of 12 hours and 25 minutes. That is for the single high and low tide combination. But usually during the high tide the basin has to fill in the one way of the turbine. Now whenever we are considering this one way of the turbine, at that time the basin will fill during high tide, and this is the time frame. Now when the basin is going to be empty, so at that time there is a variable head concept, and due to this variable head concept the turbine generator set will run. So what happens actually with the sea? So during initial case of the high tide the basin level will start filling up. So when the basin level will reach at the maximum point of the water level, at that time the gates are to be closed. And when we are getting the sufficient head to generate the electrical power, the basin will start empty, and this time is known as the generation time. So when we will reach at the negative crest of the water level, at that time the time period of the low tide will start. So over at this point of time of the basin or single basin level, the head height is too small, so we need to sluice gate closed, or gate must be closed, and again the same cycle will start for the filling up of the basin. So if you can consider that this particularly in the form of the power output, so at that time my power output will be from this head difference to the lowest head difference. So up to this point of time we are getting the power generation through one way turbine. This power output magnitude is depending upon the rating of the generator. So what we have seen in this slide is we are having a water level. So before proceed further to revise the thing, this one sinusoidal kind of cycle comprising of the two tides, that is high and low. So in the initial case we are having the high tide. At that time it is also known as flood tide, and when we are having the ebb tide, it is known as, we can say, a low tidal level. So during low tidal level the head difference will be created, and when we are having the ebbing of the tide, at that time it is the highest point of the high tide. Now when we are having the low tide, again the basin will start filling and this cycle will repeat. So the sequence is like this. If you can start with the point A, our basin level approaches the water level of the sea. At that time the basin has been filled and the gates are closed, and we are developing the sufficient head over here. Whenever there is difference of sufficient head, at that time the basin will start empties itself due to the gravitational pull, and when the head height is too small, the power generation will stop, and again the basin will fill. As we are getting the power generation in the limited period of the time, it is known as the single basin single way power generation scheme. Now if you could think about a two-way of turbine, again the shape of the scheme is very similar to the same as what we have done. You have the sluice gate, you have a basin, and you have a sea. You have a tidal variation like this as a sinusoidal manner only, and we need to go for building up of the head again. Now when it is going into the high tide, the turbines are open. At the time the turbines are open, therefore there could be a difference between two levels in order to turbine to operating in its region. But the turbine since are open, the water is going to basin from the sea, therefore it should go up. So as it should go up, the head level will also rise, and again we are developing the variable head concept of the two-way power generation. Now considering the two-way power generation, we are starting from the here. So this is what the two-way power generation during high tide. So if it is go up like this, so this is the basin water level over here. So when there is basin water level till a point where you can no longer run the turbine because the head becomes too low. When head becomes too low, again at the similar point the turbine will stop and sluice gate will close, or you might open the sluice gate till it goes to this point. Afterwards it will be stopped. The turbine cannot be functioned, but you can still open the sluice gate till the water level becomes equal, and then both are closed till some time when the head will again reach up its some value. where the turbine has to operate as a bulk turbine into the reverse direction by changing its blade orientation. So, the basin water now, the water will empty through the turbine till a time when the water level will equal, and there again approach the same cycle. Now, the thing is that the diameter of the turbine and how much water it can allow through, it is more or less constant because it is depending upon the head. But after all, the same amount of water can flow. So water is incompressible form. So the head will not make the more water or less water to flow. So the amount of water will flow with some velocity. It is depending upon the velocity of flow also, and a bit of the variable head concept. So if you can talk about the variable head concept, we are going to draw the power curve over here. So if you can draw vertical lines over here, and at this part again we will develop the power. Again, when the gates are closed and turbines are no more operating, we are having the no power generation. And in second case, again when the variable head has been developed, over here also the variable heads will be developed. So you are starting the filling of the basin and emptying of the basin. In both the cases, the power will generate through the same concept. Means when we will fill the basin, at that time also this turbine generator set is on, but during the rest of the time where we are having the open and close of the gates, and for particular little amount of time we are not having any head difference, so there will be no power from the turbine generator set. So as a whole, if you can go with the head versus power generation concept, so notice that the power generation curve will be at the same time you have the power generation stopped. At this time again it is started. As it is started, then again it has to stop, and this cycle will be repeated. At the same time it is the highest, so you have to come over here at the peak point and you will get the maximum power. And these are the regions where the no power has been there. In fact, the advantage of power generation from the tidal is that you have a free power, so it is a renewable source of the energy. But the disadvantage is that during this time there is no generation of power. As a result, unless the power system is strong enough that during this time through other means, but where the load shedding will be there or due to other means, the rest of the power is generated. So you can think about that. During this time you can have a storage of little amount of water, that is what we call stored water, at some high head, and forcefully you can empty the water to have a no power region into the at least power region, so you can run some loads during no power time. Particularly the industries find it more convenient to use that, and this period is around of 2 hours. They simply switch off and you can go outside for your activities. So the lighter note, you can go with the activities during no power region again when it will reach, because it's a natural cycle, and you can start with the power generation concept. So particularly the tidal variation is tidal range, that is what the R. So in ultimate case, what we are trying to do is we are developing the sufficient amount of head at all the time, and during this time, whenever the head has been developed in sufficient way, we are generating the electrical power output in systematic manner from the turbine. Now, if we can talk about the one more method where we can think about how to remove this intermittency of the power. So, this is what the particular time where tidal power could be generated without intermittent brainer. So before that, if you can start with the arrangement of the basin, this is the single ebb cycle. Means in the ebb cycle, particular way the basin will start filling up, and during the single tidal cycle again the basin will remain filled, but the sea water will try to push this water back into the sea. In ultimate case, we are having the filling and emptying concept of the double cycle scheme. There is one more option of double basin scheme that was covered in the previous slide. Now we will talk the same thing in detail. So what happens in particular way, if you are depending upon the tidals, at that time we are having the various tidal ranges, and depending upon these tidal ranges, if you can see this kind of topography, something like that, so you need to construct another dam over here that can be served as a lower basin. But if you can see that this is a dam over here, you are dividing a bigger basin into two basins, but upper one has the higher area compared to lower one. So this is one dam and this is another one, but turbine is not installed over here. Instead of that, turbines are installing over here, that is TG set over here. Now imagine that during high tide of period you allow this gate to be open. So when you will allow this gate to be open, at that time water goes in like this, and during low tide of period you open the gate and allow water to go outside. Again, the definition of high tide and low tide periods would be as illustrated in the previous sessions. It means that the period of low tide and this period is of high tide. So that is low tide and high tide combination, and the power will be generated. So ultimately in the power generation level, in the case of basin, it will be maintaining the relatively high water level, and this basin will maintaining the low water level. So during high tide you are allowing the water to come in, and during the low tide you are allowing the water to go out from the here, and this turbine utilizing that condition. So in the power curve we need to draw a pattern that could be matched with the water level of the sea for upper basin level and the lower basin level. So the sea water level, it could be varying like this in the sinusoidal pattern. Similarly, we are having the upper basin where we have a concept of the relative head of the single basin system is like the same. If we can think when it is filled up, when this level is reached up to its maximum level. So the water is going from the basin to the lower basin. Now what happens with this lower basin? Now the lower basin was actually, this was closed during the high tide period. So this gate is open during the high tide period at the same time. So it is only rising. Why rising? Because the water was coming in from this period. So even though the gate is closed, this thing is rising slowly because it is converting this TG set to operating mode. So when someone will open this sluice gate, then the water level will falls. It will be slightly greater than the water level in the sea, but nevertheless it falls this, and it will run, this thing will means during the continuation of the time. So when we will start with the lower basin, we can start the lower basin that could be reached up to the zero level when it will reach at this sea level reached at 0. And again you can redraw this thing for the lower basin. So now if you can do the simple power output calculation, so in particular case the question may be there in the mind that when the water in the upper basin has filled up in the first half, there will not be water leaked into the lower basin because we have a turbine. Yes, water is going to be that, but in this case we are assuming that the water is coming through the sluice gate because the sluice gate does not offer much resistance, and all the time the water is going only, not any kind of leakage that could be done. So the wave of the power generation could be, if you can noticing that even though the time that is a head maintained at all the time, that is a head could be maintained, the power generation is definitely not the constant in the magnitude, but we don't have any kind of gap of the no power generation. So the head is large during this period and it could be fall again. So the thing is that during this time, during the high head, there is a head difference over here between sea and the lower basin, and it could be experienced the rising manner. So at that time the power is also rising. Then with the differential head between these two, that is relative head difference, you will get the again power generation. Again the same thing happens in the reverse direction. So when the one, that is sluice wave 1, is open during this period till this point, so when it is closed at that time, the 1 and 2 both are closed. At that time also upper basin is emptying through TG set to the lower basin. When sluice gate 2 open, again for this period the sluice gate 2 will be open. Over here the pictorial representation is this. For the same, again sluice gate 2 will open from this point to this point, and it will again open and remain open up to this time because there is sufficient head difference, and you will get the power output. So in similarly we are getting the enough power penetration in both the cases, known as the two-way turbine power generation scheme. So as a part of this session, what we have done, how we can generate the electrical power through one-way power generation, two-way power generation, and the double basin scheme. There is also an option of single basin linked scheme. In the linked scheme, as I have mentioned, we are going to incorporate one storage of the seawater in a particular tank which can maintain the high head. So during high head the relative difference would be created and we are getting the enough amount of electrical power, though it is not sufficient enough as compared to the power generation during a two-way turbine, but we can manage the loads by incorporating this water into the power generation prime mover. So this is all about the tidal energy system session for power generation through tidal as a renewable energy source. I am thankful to everyone for your patience listening. Thank you very much.